Hi, today we are going to go through Chapter 9, Section 3, Geometric Sequences and Series. In Lesson 9.2, we looked at arithmetic sequences and series. Today we're going to look at geometric. So we're going to find partial and infinite sums of geometric sequences, and we're going to find the nth term of a geometric sequence, and we'll show you how to do that. So first of all, what is the definition of a geometric sequence? A sequence is geometric if the ratios between consecutive terms are the same. So R is equal to a sub k plus 1 divided by a sub k. What does that tell me? That a sub 1, the first term in a geometric sequence, multiplied by a ratio is going to give me the second term. The fifth term times a ratio is going to give me the sixth term. The nth term is going to be equal to the previous term, n minus 1, times that ratio. That number r is called the common ratio. The nth term of a geometric sequence has the form a sub n is equal to a sub 1 times r to the n minus 1 power. So that tells me that if I know the first term of a sequence and I know the ratio, well, I can multiply that first term by the ratio n minus 1 times to get the nth term. Now you can use any term to find the nth term using this formula. So if I know the kth element in the sequence is a sub k, well, I can multiply it by the ratio n minus k times, and that'll give me the nth term. So let's look at a couple examples here. If this is geometric, find the common ratio. Well, it's 36, 27, 18, 9. Well, I don't think that's a common ratio. It looks like more like an arithmetic sequence because I'm subtracting 9 every time. So it's got a common difference, but does not have a common ratio. So let's take a look at the next one. Here I've got 5. Well, times 1/5 would give me 1. 1 times 1/5 would give me 0.2. And 0.2 times 1/5 would give me 0.04. So yes, it is a geometric sequence. And I can figure out that the ratio is 1/5. Let's look at the third one here. 9 times negative 2/3 would give me negative 6. Negative 6 times negative 2/3 would give me 4. 4 times negative 2/3 would give me negative 8/3. So yes, that is a geometric sequence with my ratio of negative 2/3. Here I've got 1, 1/2, excuse me, 1/2, 1/3, 1/4. I see a pattern, but it is not a common ratio, so it's not geometric. All right, so let's write the first 5 terms of this geometric sequence. And what do we have? We have the first term is 6. And if my ratio is 2, well, 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. 48 times 2 is 96. So we can figure that out pretty easily. How about this one? We're going to start with the same first term, but now my ratio is negative 1/4. So 6 times negative 1/4 is negative 6/4 times negative 1/4 is positive 6 over 16 times negative 1/4 is negative 6 over 64 times negative 1/4 is positive 6 over 256, and we could go on from there if we wanted. All right. Let's take a look at the geometric sequence. We're going to write the first 5 terms, determine the common ratio, and write the nth term as a function of n. So my first term is 48, and my kth term is negative 1/2 of the previous term. So my ratio here is going to be negative 1/2. Where's my r? So what is a sub 2? A sub 2 is just simply going to be 48 times negative 1/2 is negative 24. Negative 24 times negative 1/2 is positive 12. Positive 12 times negative 1/2 is negative 6. Negative 6 times negative 1/2 is a positive 3. So my generic formula here then is my a sub 1 is 48 times negative 1/2 n minus 1 times. So for the fifth term, it's going to be 48 times negative 1/2 to the fourth power. 5 minus 1 is 4. That would be positive 1/16. So 48 times positive 1/16 would be a positive 3. Let's go over and take a look at the in-class practice now. So determine if the sequence is geometric, then find a common ratio. Well, I've got 1/8 times 1/8 times 1/8 divided by 2 is 1/4. No, I'm sorry, 1/8 times 2 is 1/4. 1/4 times 2 is 1/2. 1/2 times 2 is 1. Sorry, I got that mixed up there. So we do have a common ratio. Here, this was one like that we had in the example before. That's not geometric. So now we're going to write the first 5 terms. So a sub 1 is 1 times 1/3 is 1/3 times 1/3 is 1/9 times 1/3 is 1/27 times 1/3 is 1/81st, and so on. Here I've got a sub 1 is 2, and my r is some value x over 4. It's kind of hard to see there, but that's an x. So 2 times x over 4 would be x over 2 times x over 4 would be x squared over 8 times x over 4 would be x cubed over 32 times x over 4 would be x to the 4th over 128. All right, so now write an expression for a sub n for the geometric series, then find the indicated term. So here I've got a sub 1 is 5, my ratio is 3/2, n is equal to 8. So what is a sub n? A sub n is 5 times my ratio to the n minus 1 power. So a sub 8 is going to be 5 times 3/2 to the 7th power. And I'll use my calculator to help me out with this one. So 5 times 3/2 to the 7th power would equal this number here. Well, let's take a look at another one here. My a sub 1 is 1,000. My ratio is 1.005. So my a sub n is going to be 1,000, my a sub 1, times my ratio to the n minus 1 power. So a sub 60 is going to be 1,000 times 1.0005 to the 59th power. And if I use my calculator, it should come out to be approximately that much. All right. So find the indicated term of the geometric sequence. So we want to find the 7th term if I've got 3, 36, 432, and so on. Well, what's the 7th term? Well, I could do it by hand and write these all out, or I could do it this way. My r, it looks like, is 12, because 3 times 12 is 36. So a sub 1 is 3. My r is 12. So my a sub n is going to be 3 times 12 to the n minus 1 power. So the 7th term is going to be 3 to the 12 to the 7 minus 1, or 6th power. And using my calculator, it's going to be that figure there. Let's look at the 7th term of this sequence when a sub 3 is 16/3 and a sub 5 is 64/27. I'm going to use this formula from a couple slides back. So I can pick a sub n is equal to 5, and my a sub k is equal to, my k is equal to 3, so my a sub 3 is 16/3. My r to the 5 minus 3 powers r squared. So now I have to figure out what r is equal to. So doing a little bit of math here, r squared is equal to 64 over 27 times 3/16, okay, because I'm going to cross multiply here. That tells me that r squared is equal to 4/9, or r is equal to 2/3. So I still have to figure out what the seventh term is. So the seventh term, I can go back and use this formula again, now with n is equal to 7 and k is equal to 5. So I'm going to have a sub 7 is equal to r to the 7 minus 5 times a5, which we were given as 24/27. We figured out what r was down here, which was 2/3. 7 minus 5 is 2, so we're going to square that. So a7 is 256 over 243. I'll give you a couple seconds to get those notes down. And you can take a screenshot of this or go look at the notes later if you want to. All right. Now, how can we do some of this stuff on a calculator? Well, hopefully you were able to figure some of this stuff out for the arithmetic series and sequences. Well, we could do the same thing with geometric, except now we're going to do it like this. This is kind of the old style here. If I want to do a sub n is equal to 10 times 1.2 times the n minus 1, I could plug it in to my calculator like this. The newer ones, newer calculators, it'll look slightly different. But when n is 1, then my 1.2 to the 0 power is just 1 times 10 is 10 here. And then I could set up my window, make sure that I go to mode and set up my sequence as dot. Set my mode to sequence and dot, like we did last time. And then we can use the table function to identify the terms needed. If you want to do all of them, you can graph it, or if you want to just go to table and just ask for one, you can do that as well. So let's take a look at 5 through 8. So write the first 5 terms, determine the common ratio, and write the nth term. So if my first term is 162 and my ratio is negative 1/3, well, 162 times negative 1/3 is negative 54, times negative 1/3 is 18, times negative 1/3 is negative 6, times negative 1/3 is positive 2. So my ratio is indeed negative 1/3. And I can write it as a generic a sub n is equal to a sub 1, which is 162, times my ratio, which is negative 1/3 to the n minus 1 power. Now, write an expression for the nth term, then find the indicated term. All right, so we got the same sort of deal. I've got my a sub 1 is equal to 6. My r is equal to negative 1/3 again. My n is equal to 12. That we want to find the 12th term of this sequence. So a sub n is equal to my a sub 1 times my ratio to the n minus 1 power. So if my n is equal to 12, then this is going to be 6 times negative 1/3 to the 11th power. And we could rewrite it like this if we wanted to, or we could just calculate it and it would come out to be approximately this figure here. So number 7, my a sub 1 is 500, my ratio is 1.02, my n is 40, so 40 minus 1 would be 39. So if I plug this in my calculator, a sub 40 is equal to 500 times 1.02 to the 39th power. Should come out to be this figure here approximately. All right, let's find the 7th term of this. Well, here I go from 5 to 35, so I know that my ratio is 7. 35 times 7 would be 245. And I want to find the 7th term. So here's my a sub 1, 5. My ratio is 7 to the n minus 1 or 6th power. So if I did 5 times 6 to the 7 to the 6th power would equal 588,245. So I'll give you a second to jot those down. All right, let's go back to our all right. So using our calculators, we can figure out the finite sum of a geometric series. It would look something like this. Is equal to my first term times 1 minus r to the n all over 1 minus r. And an infinite, this is only possible if my absolute value of r is less than 1. Now I know it doesn't seem possible to have a sum of an infinite sequence, but we do if we converge to a certain number. And you can use your calculators to help you with this, but it's a little bit tricky. But it would be something like this, a to 1 minus r. So if r, the absolute value of r is less than 1, it's going to converge to a sum. Even though it's an infinite series, an infinite sequence, it's going to converge to a sum. So let's take a look at find the sum of this finite geometric sequence. It's finite because it goes from 1 to 10. Now, here I've got 5 halves to the n minus 1. I could plug this into my calculator if I wanted to, or I could do it by hand. Here, if n is equal to 1, then 5 halves to the 0th power is equal to 1. My ratio here is 5 halves. So to figure out this sequence, S sub 10 is going to be equal to 1 minus my ratio to the upper limit, 10th power, divided by 1 minus 5 halves is equal to this number here. Now, if I plugged this into my calculator, now remember again, you have to put it within the set of parentheses that they give you. Don't use this set. You're going to have an extra set of parentheses. But if you do it correctly, you should come up with the exact same number. So become familiar with how to do it on a calculator. Now, here's another finite geometric sequence. Again, here my ratio is 2/3. My a sub 1 is going to be 15. And my ratio is 2/3. So here's my a sub 1. My ratio is 2/3, which is here. So I can figure out this way again using this formula. A sub 1, 15 times 1 minus 2/3 to the 100th power divided by 1 minus 2/3. If I were to figure this out, it would be approximately 45. If I did this on my calculator, again, putting this whole thing inside of the set of parentheses they give you, it would give you 45 as well. So let's go take a look at 9 through 12 here. We're just going to plug these into our calculator and do it the easy way. You might want to practice these though to make sure you can come up with these answers. But plug it in and come up with 1031 over 16. Number 10, if I plug this into my calculator correctly, 1365 over 32. Number 11, if I plug that into my calculator correctly. Now this one, that goes from 0 to 20, so make sure that you plug that in correctly. 25 over 2. And if I do this one, I've got this number here, 3,949.147. So I would suggest practicing those on your calculator to make sure you get those values. It will help you tremendously on your homework if you know how to do that. All right, let's go back. All right. So I'll show you how to do this on your calculator, all right? So find the sum of an infinite geometric series. So the infinite is going to have the infinity symbol as the upper limit. Now that would be really hard to do by hand because you'd be here all day and night and you wouldn't even get close to the answer. But again, my ratio has to be the absolute value of my ratio has to be less than 1. Otherwise, it won't converge. So here I've got 2 times negative 2/3 at the end. Now I can figure this out by hand because my a sub 0 in this case is 2. My ratio is negative 2/3. So my sum of the infinite series is a sub 1 over 1 minus r. Well, we're going to use a sub 0 in this case. 2 divided by 1 minus negative 2/3 is equal to 1.2. So it does have a finite sum, even though it's an infinite series. Now, if I wanted to try to do this on my calculator, again, I'd need an extra set of parentheses, but this is where it gets tricky because there is no infinity symbol on your calculator. It it's not a real number. Okay, it's just a concept. So if you're going to do this on your calculator, instead of putting infinity, put a large number. Okay, now it's going to have to calculate it, so you don't want it too large, or you'll be here all for a while. But I would say something like 100. If you put 100, you know that you're going to get pretty close to what the value that you want, and it should come up to 1.2. So I would try this on your calculator and put 100 up here. Again, make sure you put all this within the set of parentheses that your calculator gives you, and make sure you can come up with that. So let's finish up with numbers 13 through 16 here. Use summation notation to write this sum. Well, I'm going to call this my first term. And if I figured it out, my ratio is 7. And I'm sorry, my initial A1 is 7 and my ratio is 2. So 7 times 2 is 14. Well, I could figure out that this term is going to be my 8th term. So 1 to the 8th, 7 times 2 to the n minus 1 power. And we could plug that into our calculator to figure out what that actually equals. Here, I can figure out that 15 is my first term. And I'm going to multiply by negative 1/5. And if I go figure it out by hand, this is my first term, my second term, my third term. I can figure out that that's going to be my 6th term. So this is going to be 15 times negative 1/5 to the n minus 1. Again, I could plug this into my calculator and come up with an answer, but I don't need to do that right now. But here, I want to do this, find the infinite sum from 0 to infinity of 1/2 to the nth power. Again, to do this on my calculator, instead of infinity, I'll put a large number like 100. I've got to put all this inside the set of parentheses that the calculator gives you. Don't put the 1/2 inside and then to the nth power. It's going to have an extra set of parentheses on your calculator. And it should go up with 2. Again, here, substitute 100 for infinity. Put this whole thing inside a set of parentheses. Should come up with 5. So I would strongly suggest practicing those on your calculator to make sure you can come up with these answers. So, because that's really going to help you on the homework. All right. All right, we are not going to have a quiz or a test coming up, but there is a WebAssign 9.3. Make sure that you get that done by next class. Again, late work gets docked 25%. That's the school policy on distance learning. So make sure you get your class in-class worksheet done, and make sure you get your WebAssign done by next class. So, all right, we're going to stop there for today.